Math 9 class with Ma'am MC, Ma'am Flores, and Sir Reynold. Hello, I am Ma'am MC, and welcome to another day of unlocking new ideas and knowledge in mathematics. So for today, I will be discussing how to solve equations transformable to quadratic equations. This includes rational algebraic equations. We will be covering your quarter 1 week 3B of your MathPacks for grade 9. So before we start with our lesson, let us have first some exercises for your brain. So we call this challenge stick challenge. Obviously because we will be needing sticks, or it involves sticks or lines. So I will be giving you 20 seconds to try the challenge, and then after that I will proceed to the next slide to reveal the answer, or to reveal the correct answer for the challenge. So are you now ready to take the challenge? So let us have the first one. So you have here 12 sticks. So the first task is to move 4 sticks to make 3 squares. So if you will be, or if you're wondering, ano yan namin kung sticks, we have here 1, this is 1 stick, and then we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 sticks in total. So all you have to do is to move 4 sticks out of 12 sticks to make 3 squares, because for now we have 4 small squares here. I will be giving you 20 seconds. You can draw your answer. You can draw the 3 boxes or the 3 squares later. And I will be giving you 20 seconds only to try this challenge, and then after that we will reveal how to, or I will reveal how to do this challenge. Okay, and your time starts now. Again, 20 seconds only. So we have 12 sticks. Move 4 sticks to make 3 squares, because for now we already have 4 squares. So we need to make 3 squares only by moving 4 sticks. And remember, all sticks must be used. Okay, and your time is up. Okay, so again, we will be moving 4 sticks only. So let us count. So I have moved 1 stick already, and then we have the second stick, and then we have the third stick, and the last stick. So we have moved 4 sticks. Now let us count how many squares do I have, or do we have. We have 1, 2, and then 3. So we have moved 4 sticks to make 3 squares. So that is how you do this challenge. Now let us proceed with the second one. Now, we have here the second one, still the same. We have 12 sticks, but this time, you will be only moving 3 sticks to make 3 squares, mangyapon. So, I will be giving you again 20 seconds for that one. So, you may start, or you may draw your sticks or your answer to this challenge sa inyong notebook or to your scratch paper. And your time starts now. Okay, so again we have 12 sticks, and you have to move only 3 sticks to make 3 squares. Again 4 sticks, 3 squares. This time we are down to 3 sticks only to make 3 squares. And your time is up. Okay, so how do we do this? So again, we need to move only 3 sticks. So let us count. We have 1, we have 2, and lastly we have 3. So we have moved 3 sticks, and we have made how many squares? 1, 2, and 3. So that is how you do this challenge. Now let us have the third challenge, which is the last one, because I have only intended 3 challenges for this one, but I can give you some if you want sa next na video tutorial. But for now, we only have 3 challenges for this. So let us have the last one. So again, we still have 12 sticks here. So what we are going to do is to remove 2 sticks. Kaya na move. So ging halin ta lang. This time remove. So we need to get rid of the 2 sticks to make 2 squares. And again, you will have 20 seconds to do that, and your time starts now. Again, 12 sticks, you will be removing 2 sticks to make 2 squares. So can you do that? Okay, and your time is up. So again, we will be removing 2 sticks to make 2 squares. So let us count. 1 and then 2. How many squares do we have? We have 1 small square and we have another square, which is the bigger one. So we have 2 squares in total. So this is how you do this challenge. And that is all for the stick challenge. So I promise to give you more on our next video tutorial. But for now, let us have our lesson proper. So much with the stick challenge. Let us now proceed with the lesson proper. So if you have the MathPacks there, or if you have your MathPacks there, you can try to scan your MathPacks because I will be discussing those on your MathPacks, especially the examples. So equations can be given in different forms, and these equations may be transformable into quadratic equations. And some of these transformable equations are rational. Now let's go back to the definition of rational. Rational numbers are numbers which can be expressed as a ratio of two quantities or two numbers. In short, they can be associated with fractions. So there is the presence of your numerator and denominator. It's the same as to your rational expressions. Now, when these equations are transformed into quadratic equations, they may be solved using different methods learned in solving quadratic equations, such as extracting square roots, factoring, completing the square, and using the quadratic formula. And I have taught you already another way to solve the roots of your quadratic equation through the use of your sum and product of the roots of your quadratic equation. So you can also use that here. Now let us have the first example on your MathPacks. So keep scanning your MathPacks because I will be discussing those examples there. So let us have solve x squared over 2x is equal to 3. Now try to notice that this equation here is a rational equation because there is the presence of your rational expression. So there is your numerator, which is the x squared, and your denominator as 2x, or your 2x as the denominator. So the first step to solve this rational equation is to eliminate the denominator by multiplying both sides of the equation by the least common denominator, or LCD. So the least common denominator is the least expression which can be divided by all of our denominators. But luckily for this particular example, we only have 2x as the denominator. That means to say automatic 2x will be your LCD. So you don't have to think of the LCD because 2x here will become your LCD. So the first step again to solve for this rational equation is to transform this equation into quadratic equation by multiplying both sides of the equation by its LCD, which is again 2x. So x squared over 2x will be multiplied to 2x, and then 3 will be multiplied to 2x as well. And then after that, we need to simplify. 2x times x squared over 2x, we can cancel out 2x because 2x divided by 2x is just equal to 1. 1 times x squared, that is x squared. 3 times 2x is equal to 6x. So now we have our quadratic equation, x squared is equal to 6x. So how do we know that this is quadratic equation? Obviously, because we have here the highest exponent of our variable x is equal to 2. Or our equation is in second degree. So this equation is in quadratic equation, but this is not yet in standard form. So the next thing that we need to do after this one is to transform or to express this equation into standard form. So again, the second step is to express the resulting quadratic equation in standard form by adding negative 6x to both sides of the equation. So if we have x squared equals 6x, we need to add 6x here, both sides of the equation, by negative 6x. But why do we have to add both sides of the equation by negative 6x? So in order for us to have this side of the equation equal to 0, because if we add 6x by negative 6x, the answer will become 0. So this this negative 6x is called the additive inverse of 6x. Additive inverse is just similar term or similar expression but of different sign. So if we have 6x to be positive, its additive inverse is negative 6x. So when we add 6x and negative 6x, that is equal to 0. Now, if you are going to add negative 6x to this side to make this one 0, you must add as well negative 6x to the other side of the equation. So we add x squared by negative 6x and we add 6x by minus or by negative 6x. So x squared plus negative 6x is x squared minus 6x. We have merged these two operations here, positive and negative. So positive and negative is just equal to negative. That is why we have here subtraction. And we cannot combine these two terms because they are not like terms. This one obviously has 2 as its exponent, and here we have 1. So they are not like terms. So we cannot combine them. So we have x squared minus 6x. And 6x plus negative 6x is equal to 0. So the quadratic equation in standard form is now x squared minus 6x is equal to 0. Now, there is another way to express our equation into the standard form. So we can just simply transpose 6x to the other side of the equation. But remember, if we do transposing, we need to change the sign of the term to its opposite sign. So if 6x here is positive, if we transpose 6x to the other side, it will become negative. So do not forget to change the sign of 6x to negative 6x, or to negative rather. So we copy x squared and then we change the sign of 6x to negative, so that is why we have minus 6x, and what is left on the right side is just 0. So we have here x squared minus 6x is equal to 0, similar to the first one we got. So the next thing that we need to do is to find the roots of the equation using any algebraic method of solving quadratic equation. So in this particular equation, we will be using factorization or factoring. So x squared minus 6x is equal to 0. In order for us to factor out x squared minus 6x, we need to look for the common factor of x squared and negative 6x. So we need to look for a certain expression which can divide x squared and which can divide negative 6x. And that expression is actually 1. Or x rather. So x is one factor. So in order for us to get the other factor of x squared minus 6x, we need to divide this by x. So x squared divided by x is equal to x. Negative 6x divided by x is negative 6. So the two factors of x squared minus 6x are x and x minus 6. Now, we then equate each of the factor to 0. So we equate x to 0, so that is x is equal to 0. This is already one solution of your quadratic equation, x squared minus 6x is equal to 0. To get the other solution, or to get the other roots, we need to equate x minus 6 to 0. So x minus 6 is equal to 0. Transpose negative 6 to the other side of the equation, so it will become positive. So x now is equal to positive 6. This is another solution for your quadratic equation, x squared minus 6x is equal to 0. But remember that even though these two are solutions for your quadratic equation, there is no guarantee that these two are the solutions for your original equation. Now let's go back to your original equation. Your original equation is x squared over 2x equals 3. So to know whether these two are solutions of our original equation, we need to substitute these values of x into our equation. So let us start with x is equal to 0. So we need to substitute 0 to every x in this equation. So instead of writing x squared, we write 0 squared. Instead of writing 2x, we write 2 times 0, and that will be equal to 3. Now we simplify. So 0 squared is equal to 0. 2 times 0 is equal to 0. Now, the question is 0 over 0 equal to 3? What is 0 over 0? 0 over 0 is actually indeterminate, meaning we cannot determine its value. So obviously, this 0 over 0 is not equal to 3. Therefore, x is equal to 0 is not a solution of your original equation, x squared over 2x equals 3. Now let's try the other solution. X is equal to 6. So we substitute again the value of our x, which is 6, to our equation. So x squared became 6 squared. 2x became 2 times 6, and that will be equal to 3. 6 squared is 36. 2 times 6 is equal to 12. So is 36 over 12 equal to 3? So what is 36 over 12? 36 over 12 is 3. So 3 is equal to 3. So the left side of the equation is equal to the right side of the equation. Therefore, x is equal to 6 is a solution of this equation, x squared over 2x equals 3. So the roots are 0 and 6. So these are the solutions of your quadratic equation. The solution x is equal to 0, however, is not the solution because it makes the denominator equal to 0 if we are going to go back with the original equation. So therefore, x is equal to 0 is an extraneous solution. By definition, an extraneous solution is a number obtained when solving an equation that is not a solution to the original equation. Therefore, it is a solution of your quadratic equation. And nabuol natin out of the given equation. But then, if you are going to substitute this value to our original equation, then the two sides of the equation will not be equal. So it does not satisfy the original equation. Therefore, it is not a solution but rather an extraneous solution. So the solution x equals 6 satisfies the rational equation. Thus, the only solution is x is equal to 6. Again, to make things clear, x is equal to 0 and x is equal to 6 are both solutions of x squared minus 6x equals 0, which was derived from our original equation. But if we go back to our original equation, the only solution that we have is x is equal to 6, because obviously if we substitute 0 to this one, this will become 0. So it will become indeterminate or undefined. So hindi ito pwede. So that means to say x is equal to 0 is not a solution, but it is an extraneous solution. Now let us proceed with the second example. So example number 2. Solve x squared minus 2 over x plus 3 is equal to 2. So notice again that this is a rational equation, so there is a need for us to transform this one into a quadratic equation. So the first step again is to multiply both sides of the equation by the LCD to eliminate the denominators. So in the given equation, the LCD is x plus 3 because obviously x plus 3 is the only denominator in this equation. So automatic, x plus 3 is your LCD. So we multiply x squared minus 2 over x plus 3 by x plus 3, and then we multiply 2 by x plus 3. And then we simplify. So we can cancel out this 2 because x plus 3 over x plus 3 is just equal to 1, and 1 times x squared minus 2 is just equal to x squared minus 2. And then we distribute 2 to the binomial x plus 3. So we need to multiply 2 to x, and then we multiply 2 to 3. 2 times x is equal to 2x, and 2 times 3 is equal to 6 or positive 6. So we have here our quadratic equation. X squared minus 2 is equal to 2x plus 6. But this quadratic equation is not yet in standard form. So our next step will focus on expressing this quadratic equation in standard form. So the second step again is to write the resulting quadratic equations in standard form. So we have x squared minus 2 is equal to 2x plus 6. So in order to express this quadratic equation into standard form, we need to transpose 2x and 6 to the other side of the equation. And do not forget to change the sign of 2x and 6 when we transpose them. We can also use the other method of adding both sides of the equation by the additive inverse of 2x and 6, but if it is easier for you to use the transposing, then you can always use that one. So we copy x squared minus 2, then we transpose 2x to the other side, so we have negative 2x, and then we transpose 6 to the other side, so we have negative 6. And what is left on the right side will be 0. So we have x squared minus 2 minus 2x minus 6 is equal to 0. But this is not yet in standard form, because as you may notice, we still have like terms here. We have negative 2 and negative 6, so we can still combine them. So we copy x squared minus 2x, then we combine negative 2 and negative 6. So since they have the same sign, we can just add them and we copy their common sign. So 2 plus 6 is equal to 8. Their common sign is negative. That is why we have negative 8 or minus 8. So this is now our quadratic equation in standard form. X squared minus 2x minus 8 is equal to 0. And then, step number 3, find the roots of the quadratic equation using any method of solving quadratic equations. So this time we will be using factorization again. But unlike the first example, we have here trinomial. So if we are going to look for the common factor of these three terms here, we can only think of 1. So 1 is the only factor, common factor of x squared, negative 2x, and negative 8. So we cannot use the one that we have used from the previous example. So in this case, we need to think of other ways to factor out this quadratic expression. So we will be using the sum and the product. So the product here is negative 8 and the sum is negative 2. So you need to think of two numbers whose product is negative 8 and whose sum is negative 2. So we have here your product is a negative number. So the only chance that we are having a negative product is if we have one number to be positive and the other number is negative. So that is our first clue. One number is positive and the other number is negative. So we need to think of two numbers whose product is negative 8 and whose sum is negative 2. And those two numbers are negative 4 and positive 2. If we multiply negative 4 to 2 or to positive 2, that is equal to negative 8. If we add negative 4 to positive 2, that is equal to negative 2, because the rule says if they have different sign, then you need to subtract and then you copy the sign of the bigger number. So in this case, 4 is the bigger number. So we copy the sign of 4, which is negative, or we copy the sign. So we have here negative. Negative ang yung mga middle number, so therefore, ang taas mo number is negative. And the other one, obviously, is positive. So we have here your factors, x minus 4 times x plus 2. Now, diin ka nagbuhos sang dalawa ka ka x. Remember, our quadratic term here is x squared. So for our factors, it will always be x for the first factor and x to the next factor. So we have x minus 4 times x plus 2 is equal to 0. The next thing that we need to do is to equate each factor to 0. So we equate x minus 4 to 0. So we have x minus 4 is equal to 0. Then we equate x plus 2 to 0. So we have x plus 2 is equal to 0. And in order for us to get the values of x, we need to transpose negative 4 to the other side of the equation. So that will give us x is equal to positive 4. And we transpose again positive 2 to the other side of the equation. That gives us x is equal to negative 2. So our two solutions are x is equal to 4 and x is equal to negative 2. Now, we check again with our original equation. Our original equation, x squared minus 2 over x plus 3 is equal to 2. So we need to substitute each of this value sa ating original equation. Then we check if whether each value satisfies our original equation. So first we have x is equal to 4. So we substitute every value of x here by 4. So instead of writing x squared, we write 4 squared minus 2 over 4 plus 3. And that must be equal to 2. Then we simplify. 4 squared is equal to 16 minus 2 over 4 plus 3 is equal to 2. 16 minus 2 is equal to 14. 4 plus 3 is equal to 7. Now, is 14 over 7 equal to 2? So, 14 over 7 is equal to 2. So, 2 is equal to 2. So, therefore, x is equal to 4 is a solution of this rational equation because it satisfies this equation. Now, let us try for x is equal to negative 2. So we substitute again negative 2 into this equation. So instead of writing x squared, we write negative 2 quantity squared. Again, do not forget to enclose your negative 2 inside a parenthesis. That is to denote that we are squaring both 2 and the negative sign. So negative 2 quantity squared minus 2 over negative 2 plus 3, and that must be equal to 2. Then we simplify. Negative 2 squared is negative 2 times negative 2, so that is positive 4 minus 2 over negative 2 plus 3. Is that equal to 2? Now, 4 minus 2 is equal to 2. Negative 2 plus 3 is equal to positive 1 because negative 2 and 3 have different signs. So the rule says you need to subtract them, then follow the sign of the bigger number. So we follow the sign of 3, so that is positive. So that is why we have here positive 1. So 2 divided by 1, is it equal to 2? So 2 divided by 1 is equal to 2. So 2 is equal to 2. So indeed, 2 or negative 2 is a solution of your rational equation x squared minus 2 over x plus 3 is equal to 2. So let us have example number 3. So solve 8x squared or 8x over 2 plus 75 over x is equal to 7x. So again, the first step is to multiply both sides of the equation by the LCD to eliminate the denominators. Now notice that in this kind of equation, we have two denominators. So we cannot say that 2 is the LCD or x is the LCD. But in this case, since 2 and x has no common factor except 1, then our LCD will be the product of these two. So that is why the LCD for this equation is 2x. Again, if you have two or more denominators and if their common factor is just equal to 1, then the LCD of that particular equation will be the product of your denominators. So we multiply both sides of the equation by 2x. So multiply 8x over 2 plus 75 over x by 2x, and we multiply 7x by 2x as well. So do not forget to enclose this one into a bracket because that would mean that 2x is being multiplied to both the 8x over 2 and 75 over x. Without this bracket, then 2x will be multiplied to 8x over 2 only, which is very wrong because we are multiplying 2x to the whole left side of the equation. Now we simplify. 2x will be multiplied to 8x over 2, and 2x will be multiplied to 75 over x, and as well as 7x to 2x. Now 2x times 8x over 2. So we cancel out 2 because 2 divided by 2 is just equal to 1. And then what is left is x. X is then multiplied to 8x, and that will give us 8x squared. 2x times 75 over x, common factor natin or common term will be x. So x divided by x is just equal to 1. So we multiply 2 to 75, that is equal to 150. And 7x times 2x is 14x squared. So our quadratic equation is 8x squared plus 150 is equal to 14x squared. But remember, this quadratic equation is not yet in standard form. So since 8x squared plus 150 is equal to 14x squared is not yet in standard form, the next thing that we need to do is to write the resulting quadratic equation in standard form. So 8x squared plus 150 is equal to 14x squared. We need to transpose again 14x squared to the other side. But again, do not forget to change the sign of 14x squared. Since 14x squared here is positive, when we transpose it to the other side, it will become negative. So we copy first 8x squared plus 150, then we transpose 14x squared to the other side. That is why it became negative 14x squared. And what is left on the right side is just equal to 0. Then we have common terms here. 8x squared and negative 14x squared are like terms because we have here your variable x. Both has 2 as its exponent. So therefore, these two terms are like terms, so we can still combine them. So in combining them, we only focus first with our coefficients or the number beside your variable. So we have 8 and 14. So 8 minus 14. So since 8 is positive and 14 is negative, so the rule says we need to subtract. 14 minus 8 is equal to 6. Then we copy the sign of 14 because 14 is bigger than 8. So that makes negative 6 as the sum of 8 and negative 14, or the difference between 8 and 14. Then we copy their common variable and exponent, which is x squared. So we have negative 6x squared. Then we copy 150 equal to 0. Now, since our leading coefficient here or leading term here is still negative, or our quadratic term here is still negative, then we cannot say that this is in standard form, because usually if we have standard form, we see to it that the quadratic term is always positive. So we need to multiply still both sides of the equation to negative 1, so that this negative sign right beside the 6 will be eliminated. So we multiply again both sides of the equation by negative 1. So negative 1 times negative 6x squared is just positive 6x squared. Negative 1 times 150 is negative 150. And 0 times negative 1 is just equal to 0. Making our quadratic equation in standard form equal to x squared minus 150 equals 0. We now proceed to the step 3. Find the roots of the quadratic equation using any methods of solving quadratic equations. So this time we will be using extracting the square root. 6x squared minus 150 is equal to 0. Now, in order for you to solve this quadratic equation easier, we need to get rid of the 6 of the coefficient of your x squared. So how do we do that? We need to divide both sides of the equation by 6, or multiply both sides of the equation by 1 over 6. So 1 over 6 times 6x squared is equal to x squared, because 6 divided by 6 is just equal to 1. And then we multiply as well 1/6 to negative 150. So 150 times 1/6 is just the same as multiplying 150 to 1 divided by 6. So 150 times 1 is equal to 150 divided by 6, that is 25. So that is negative 25. And 0 times 1/6 is just equal to 0. So our new equation now is x squared minus 25 is equal to 0. We will be using extracting square root to get the roots of this quadratic equation. We transpose negative 25 to the other side. So if we transpose again negative 25 to the other side, this will become positive. That is why we have x squared equals positive 25. Our target here is to get the value of x. So we need to get rid of this 2, or the exponent 2. So to get rid of that exponent 2, we need to get the square root of both sides of the equation. So we need to get the square root of x squared and square root of 25. Square root of x squared is equal to x. Square root of 25 is positive negative 5. It's both positive and negative, because if we square positive 5, it's equal to positive 25. If we square negative 5, it's just equal to positive 25. So the square root of 25 is both the positive value and the negative value of your 5. So x now is equal to positive 5 and x is equal to negative 5. But then again, we don't have any assurance that these two solutions are also solutions of our original equation. So we need to check. So we have here our original equation, 8x over 2 plus 75 over x is equal to 7x. So we substitute first, x is equal to 5. So instead of writing 8x, we write 8 times 5 over 2 plus 75 over x. X will be replaced by 5. So 75 over 5. And that is equal to 7x, or 7 times 5. And then we simplify. 8 times 5 is equal to 40 over 2. Then we copy all the rest. 75 over 5. And then that is equal to 7 times 5, which is equal to 35. 40 divided by 2 is equal to 20. 75 over 5 is equal to 15. So is 20 plus 15 equal to 35? So 20 plus 15 is indeed equal to 35. So 35 is equal to 35. So the left side of the equation is equal to the right side of the equation, making x is equal to 5 a solution for our original equation 8x over 2 plus 75 over x equals 7x. Now let's check the other value. X is equal to negative 5. Again, we substitute negative 5 into this equation. So instead of writing 8x, we write 8 times negative 5 over 2 plus 75 over negative 5. And that is equal to 7 times negative 5. Again, substitution means we need to replace every x in this equation by the given values. In this case, negative 5. Then we simplify. 8 times negative 5 is negative 40 over 2. 75 over negative 5 and 7 times negative 5 is negative 35. Negative 40 divided by 2 is negative 20. 75 divided by negative 5 is negative 15. Now, is negative 20 plus negative 15 equal to negative 35? Now notice that negative or 20 is negative and 15 is also negative. They are both negative. They have the same sign. So the rule says you need to add them and follow their common sign. So 20 plus 15 is equal to 35. We copy their common sign, which is negative. That is why we have negative 35. So negative 35 is equal to negative 35. So let me put a negative sign here because this should be negative 35. So negative 35 is equal to negative 35, or both sides of the equation are equal. So we can say that x is equal to negative 5 satisfies this equation. Thus, x equals negative 5 is also a solution for this original equation. So both values x is equal to 5 and x is equal to negative 5 satisfy the rational equation. Thus, the solutions of the given equation are x is equal to 5 and x is. Now, let us have some exercises. So the direction is the same on your MathPacks. So we need to transform each of the following equations into a quadratic equation in the form of ax squared plus bx plus c is equal to 0, and then solve for its solutions. So I have just picked 4 examples or 4 similar examples from your exercises on your MathPacks. So you can compare and you can use this one to solve for the exercises. You only have to answer five exercises out of 10. So just pick 5 and then write it on your paper. So let us have the first exercises, or exercise number 1. So we have here 1 over x squared is equal to 25. So 1 over x squared is equal to 25. So we need to look for the LCD because we will be multiplying both sides of the equation by the LCD. Now, since this equation has only one denominator, obviously x squared will become our LCD. So the first step that we are going to do to solve for this rational equation is to multiply both sides of the equation by the LCD, which is x squared. So we multiply 1 over x squared by x squared, and we multiply 25 by x squared. Then we simplify. Now, x squared divided by x squared is just equal to 1. 1 times 1 is equal to 1. And then 25 times x squared is equal to 25x squared. Next thing that we need to do is to multiply both sides of the equation by 1 over 25. Why 1 over 25? So we are just looking for the value of x. So we need to get rid of this 25 here first. So matamaton na lang. Unang to si 25, then later we will be getting rid of this exponent 2. So to get this 25, we can divide both sides of the equation by 25, or we can just simply multiply both sides of the equation by 1 over 25. So we multiply 1 by 1 over 25, and we multiply 25x squared by 1 over 25. So 1 times 1 over 25 is just equal to 1 over 25. On the right side of the equation, 25x squared times 1 over 25, 25 will be cancelled out because 25 divided by 25 is just equal to 1. X squared times 1 is just equal to x squared. So we have 1 over 25 is equal to x squared. In the next step, we extract the square root of each side of the equation. So why do we have to extract the square root? To get rid of this exponent 2. So to get rid of this exponent 2, we need to extract the square root of both sides of the equation. So we get the square root of 1 over 25 and we get the square root of x squared. Square root of 1 over 25 is positive negative 1/5. So if we have fraction here inside your radical symbol, then we need to get the square root of the numerator and as well as the denominator. Square root of 1 is equal to 1, square root of 25 is equal to 5. So it's both positive and negative 1 over 5 or 1/5. And square root of x squared is just equal to x. So positive negative 1/5 is equal to x. Or we can switch their places. So we can place x on the left side and the positive negative 1 over 5 to the right side through your symmetric property. So x now is equal to positive negative 1/5. So x is equal to positive 1/5 and x is equal to negative 1/5. Now let us proceed with example number 2 or exercise number 2. 5 over x plus 6 over x squared is equal to negative 1. Now, for this particular example, we have two denominators. So we need to decide which of the two denominators is the LCD. Now, we need to think of the term which can be divided by both the x and the x squared. And obviously, that is x squared. We can divide x squared by x and we can divide x squared by itself. So, the LCD for this particular equation is x squared. So, we need to multiply both sides of the equation by the LCD, which is x squared. So, multiply the left side of the equation by x squared and the right side of the equation by x squared. Then we simplify. X squared times 5 over x. X squared divided by x is x. Multiply that to 5, we have 5x. X squared divided by x squared is 1. Multiply that 1 to 6, that is equal to 6. And negative 1 times x squared is negative x squared. You don't need to write 1 here because it is all obvious that the coefficient here is 1. And then we add both sides of the equation by x squared. X squared is the additive inverse of negative x squared. So we need to add both sides of the equation by x squared, or we simply transpose negative x squared to the other side of the equation. So this is negative x squared. So we transpose negative x squared to the other side of the equation. Again, do not forget that we need to change the sign of x squared into positive. So x squared is now positive x squared. We copy 5x and then we copy 6. And that will be equal to 0. So this is now the quadratic equation in standard form. X squared plus 5x plus 6 is equal to 0. Now we are ready to solve for the roots using factorization. So for your factorization, again, we need to take into consideration the 6 and the 5 here. 6 is the product, 5 is the sum. So we need to think of two numbers whose product is equal to 6 and whose sum is equal to 5. So since this is positive, so our two numbers are either both positive or both negative. But then, ang middle sign natin is positive. So that means to say both our numbers are positive. So we need to think of two numbers, two positive numbers whose product is 6 and whose sum is 5. And those two numbers are 2 and 3. Because if we multiply 2 and 3, that is 6. If we add them, that is equal to 5. So our factors are x plus 3 times x plus 2. They are both positive. Then we equate each factor into 0. X plus 3 is equal to 0. X plus 2 is equal to 0. Then to solve for the value of x, we need to transpose positive 3 to the other side. So since this is positive on the left side, if we transpose them, or if we transpose this to the right side, then this became negative. So x now is equal to negative 3. And then x plus 2 is equal to 0. So we transpose positive 2 to the other side of the equation. So x now is equal to negative 2. So the solution for this particular example, or for this particular exercise, are negative 3 and negative 2. Now let us have exercise number 3. We have 1 over 2x squared plus x plus 11 over 2x squared equals 1 over 4. So again, we need to look for the LCD. So here we have three denominators, 2x squared, and 4. So we need to look for a term which can be divided by all of these denominators. So which can be divided by 2x squared and by 4. Now we'll try with the coefficient first. We have here 2 and 4. What do you think is the LCD if we have 2 and 4 as the denominators? So the least number which can be divided by both 2 and 4 is 4. So that is our LCD, 4. And then since we have here both the two denominators have x squared, then we can just copy the x squared. So our LCD will be 4x squared. So 4x squared can be divided by 2x squared, and 4x squared can be divided by 4. So we multiply both sides of the equation by our LCD, which is 4x squared. So multiply the left side of the equation by 4x squared, and multiply the right side of the equation by 4x squared. So 4x squared times 1 over 2x squared. 4 divided by 2 is 2. X squared divided by x squared is 1. So 2 times 1 here, it's just equal to 2. So na-cancel out si x squared. Again, divide lang natin si 4 kag si 2. So that is equal to 2. Next, 4x squared times x plus 11 over 2x squared. Again, we can just cancel out the x squared. And then 4 times 2, or divided by 2 rather, is equal to 2 times x plus 11. So enclose x plus 11 into a parenthesis. That is to denote that 2 is being multiplied to x and 11. And then this is equal to, 4 divided by 4 is just equal to 1. So what is left is x squared. Then we simplify by distributing 2 to x plus 11 and transposing x squared to the other side of the equation. So we distribute 2 to x plus 11. So that means to say we need to multiply 2 to x and multiply 2 to 11. And then we need to transpose x squared to the other side of the equation. So transposing x squared to the other side of the equation, it will change the sign. So from being positive, it will become negative x squared. We copy 2, and then we distribute this one. 2 times x is equal to 2x. 2 times 11 is equal to 22. And what is left on the right side is just equal to 0. Then we simplify by combining like terms by adding 2 and 22. So our like terms here are 2 and 22. So it should be 2 and 22, not x squared and 2x. So 2 and 22 is equal to 24. So we copy negative x squared. Then we have here 2 plus 22, that is 24. And then we also copy 2x. So our equation now is negative x squared plus 2x plus 24 is equal to 0. And since our quadratic term here is still negative, we multiply both sides of the equation by negative 1. So by multiplying by negative 1, all of the signs or operations on the left side of our terms will just change. So negative x squared will become positive x squared, plus 2x will become minus 2x, and plus 24 will just be equal to negative 24. And that will be equal to 0, because 0 times negative 1 is still equal to 0. So our new equation here is x squared minus 2x minus 24 equals 0. Now, since we have already x squared minus 2x minus 24 equals 0, we are now ready to factor the quadratic equation. So negative 24 here again is the product and negative 2 is the sum. So we need to think of two numbers whose product is negative 24 and whose sum is equal to negative 2. Since our product is negative number, that means to say one number is positive and the other is again negative. And since this one is 2, meaning the difference of those two numbers is equal to 2. So the factors of 24 whose difference is equal to 2 are 6 and 4. 6 times 4 is equal to 24. 6 minus 4 is equal to 2. And which of the following numbers is positive and which is negative? So 6 is negative, 4 is positive because the middle term here is negative. So, ang hanggon nga number will follow the sign of the middle number or the middle term. So, that means to say our factors are x minus 6 and x plus 4. We then equate each factor to 0. So, x minus 6 is equal to 0 and x plus 4 is equal to 0. So, in order for us to get the value of x, we transpose negative 6 to the other side of the equation. So negative 6 will become positive. So x is equal to positive 6. And to solve for the other value of x, we transpose positive 4 to the other side. So x will become negative 4. So the two solutions of our quadratic equation are 6 and negative 4. Now let us have exercise number 4. So we have here 10 over x plus x is equal to 7. So the LCD for this particular equation is x because we only have one denominator. So we multiply both sides of the equation by the LCD, which is x. So we multiply the left side of the equation by x and the right side by x. So x times 10 over x is equal to 10. We just canceled out the x. And then x times x is equal to x squared. 7 times x is equal to 7x. After that, we add both sides of the equation by negative 7x, which is the additive inverse of 7x, or we simply transpose 7x to the left side of the equation. So to transpose 7x to the left side of the equation, we need to change the sign. So we copy x squared and we have arranged it already in such a way that we will have the standard form of the quadratic equation, ax squared plus bx plus c is equal to 0. So unahon always ang quadratic term, and then we have the linear term, and lastly, your constant term. So we copy x squared, and then 7x transposed to the left side of the equation will become negative 7x. Then we copy positive 10, and that will be equal to 0. And after that, we factor the quadratic equation. So we need to think of two numbers again, wherein the product is 10 and the sum is negative 7. So since this product is positive, then the numbers are either both positive or both negative. But since the middle term here is negative, so that means to say both numbers are negative. So you think of two numbers whose product is 10 and whose sum is 7. So we have 2 and 5, and those two numbers are both negative. So the factors are x minus 5 and x minus 2, and that will be equal to 0. We then equate each factor to 0. So x minus 5 is equal to 0, x minus 2 is equal to 0. And to solve for the value of x, we transpose negative 5 to the other side of the equation. X now is equal to positive 5. And we also transpose negative 2 to the other side, then x now is equal to positive 2. So our two solutions are x is equal to 5 and x is equal to 2. Now, you might be wondering, for our examples, we have checked whether our values or our solutions are solutions of the original equations, but this time we are not checking. Now, 5 and 2 are solutions. You can check, but if the time is not kumbaga, hindi enough, then it's okay if you will not going to check. Basta, ang ilantaw nyo lang always is the denominator. Just see to it that your denominator will not be equal to 0 if you substitute any of the solution. So if we substitute 5 into our denominator, then the answer is, or the denominator will become 5. It's not 0. So it's safe to say that 5 is indeed a solution of our rational equation. Now, if, say for example, x here is equal to 0, then we substitute it here as a denominator, and this will be equal to 0. That's the time that we can say that we have extraneous root, just like with the first example kanina. Okay? So you don't have to check every time. You just check if duwa-duwa ka mo nga basi na may denominator na may equal to 0 if we substitute one of the solutions. And finally, we're done. I hope you learned something today. So again, if you have any questions, just feel free to message us or to comment down below, because we will try our best to answer all your questions. So see you again on our next video tutorial. Bye!